Okay, question 11. What happens when a liquid is being heated at its boiling point? This one is in your thermal property chapter. You need to know that when your liquid is at boiling point, it will boil. It will change from liquid to gas. And you also need to know that the temperature will remain constant. Okay, so these three things will happen. And when you have liquid to gas, what happens in the molecule? Basically, the molecules, okay, will become longer and longer and it will break. Okay, so let's look at from the bottom to the top. Total number of molecule increase. Now, total number of molecule increase will only happen when you add things in. So, total number of molecule increase refers to increase in mass. Will you increase in mass when you boil things? No, right? It doesn't increase the number of particles. You have 40 kg of water. You boil it, you will still get 40 kg of water vapor, right? You won't get 45 kg of water vapor, right? Unless you know magic. Okay, so that's why D is wrong. Okay, temperature of the liquid increase when things boil, when they are changing state, the temperature remain constant. So this is wrong. The size of the liquid molecule increase. Now, the size of the liquid will increase, but the molecule will not increase. What it means? If you have H2O, okay, when you heat it up, this molecule will remain H2O. It will not become bigger. It will not become smaller. Okay, it is the bonds between the two molecules become bigger because the bond has to be broken. So the size of the molecule does not increase. It remains the same. A. Intermolecular spacing increase. This is true because when you heat up a liquid into gas, the intermolecular force will be overcome. That means the intermolecular bond, this bond will be broken. And when they are broken, they are free to move. That's why they expand. So that's why your intermolecular spacing increase. What do you mean by intermolecular? This word inter means between. This is like a Latin word for between. So you can actually interchange this word. The spacing between molecule increases. That's true, right? Because liquid bonds, I use fingertip. Liquid bonds are close to each other. When it is heated, then it fly away. It becomes free. Yeah? So that's what happened. Okay, then after that, your question 12. Okay, question 12 is your typical heating curve. We call it a curve, but you can think of it as steps. Okay, so you heat it up. Okay, it is ice at the beginning. Ice at the beginning meaning that it is a solid. Meaning that this whole thing started off as solid. Okay, what does this flat line represent? Just now in the question, we just said that when things are changing state, the temperature remain constant. Remain constant means the temperature doesn't change with time. This is a graph between temperature and time. So a flat line means that the temperature does not change with time. So what happened here? Yes, it will change its state. So in this case, it's melting because the temperature is increasing. Then this one becomes liquid. Change state again, this means that it is boiling. Okay, so between which 2 points on the graph does the beaker contain a mixture of liquid and gas? Now this is a good question. Now usually when things are completely melted, you become liquid. And if it has not melted, it is a solid. So what happened between this point and this point? It melts, right? And during melting, you will have solid plus liquid together. So similarly, when something boils, you have liquid plus gas. Okay, so in this case, I think the answer, if you know about this content, okay, this is from your textbook. If you know about this content, it will be very obvious. It will be, okay, you want liquid and gas, it will be Y and Z. D. Okay, your question 13. Question 13, it is about evaporation. So when you are getting out of the swimming pool, if you are getting out of the swimming pool, basically you are wet, right? Right. So what happens is that there will be a layer of water around you. I just draw a bit lah. So this one is a layer of water. Okay, because you are wet. So what happened? You have this layer of air, a layer of water around you. Air is a bad conductor of heat. So yes, there will be a layer of air around you. Okay, now the thing about this is that you must understand what it means by feeling cold. You feel cold because you are losing heat. Okay, this explains why you are feeling cold. So if this layer of air is a bad conductor, it means that this heat cannot be conducted away very fast, right? Bad conductor means that the conduction is very slow. This means that conduction is very slow. So if conduction is slow, it means that you are losing heat very slow, right? Then it means that you won't feel cold, right? Correct or not? So that's why this is the wrong reason. Okay, air being a bad conductor actually helps you feel warmer. It doesn't make you feel cold. Okay, then you look at convection occur in air. Convection occur in air? Yes, you are hotter than the surrounding air, but you are dry, convection will still happen. You are wet, convection will still happen. But why is it that when you are wet, you feel cold? So you know that convection is not the thing that explains why when you are wet it is cold, right? Yeah, because you compare, you are dry, convection will happen. You are wet, convection will also happen. So if both things also happen, then it does not explain why is it that wet you feel cold, right? So that's why this is wrong. Water is a good conductor of heat. This is factually wrong. Water, it is a bad conductor of heat. Okay, D, water evaporates from the skin. This is the correct reason. Okay, why? Because when these water particles around you, it gains the energy from your body, and with that energy, it becomes vapor, and when it becomes vapor, it leaves the skin surface. So what it means is like, after it take the energy from your body, it just jump into the atmosphere and leave you. So if your body has 1000 joules, you have some water particle around you. The water particle take 10 joules from you and then leave as a vapor. Your body will have 10 joules less. Okay? And if you have a lot of water particle around you because you're wet, and all of them leave you and took 10 joules away from you as they leave, of course you will be left behind with lower energy. And that's why you feel cold. Okay, so that's why D is the answer. Okay, question 14. Question 14, it is about your evaporation again. So evaporation will occur when there is enough energy, right? That's why when evaporation occurs, you feel cold. So at question 14, you need to know two things. Evaporation, what does it do? It must take in energy so that there is enough energy to leave as gas particle. And it will be easier for them to leave, right, when it is close to the surface. So what I usually do is that I tell students, imagine this is an MRT door, and you are trapped with a lot of passengers inside the cabinet. So which one is easier for you to leave? Number one, you must be very strong. You have a lot of energy, you can push the people away so that you can get out of the MRT station, right? And number two, if you are near to the door, you can get out easily. Okay, just compare between A and C. One nearer to the door, nearer to the surface. One very far away from the door, very far away from the surface. Which one easier to get out of this boundary? Of course, it's the one nearer to the surface, right? Because it's nearer to the door. So if you know that it is nearer to the door, you know that C and D is wrong already. Correct or not? So only between A and B. And between A and B, the one with the more energy will able to chung out first, right? the one that can run. So you just imagine A is a 16 years old teenage boy. B is a 80 years old 老阿公. 老阿公 has low energy, right? The teenager has high energy, right? So which one can get out first? Of course the teenager, right? Correct or not? So it will be the teenager standing next to the door. So it will be the molecule with high energy standing near to the water surface will get out first. So that's why A. Okay, question 15. Question 15 is about your wave. So when you look at wave, look at the axis first. This is displacement, this is distance, meaning that one full wave will tell you the wavelength. Okay, so what is one full length? Let's try a pick one wave. This is one wave. This is half a wave. Right, this is one wave. So how many wavelengths are between P and Q? 1.5 wave. See. Okay.